Hello everyone. My name is Ripon Padgiri from National Institute of Technology, Silisor, Assam, India. Today I am going to present HFil, a high accuracy bloom filter. These are my content outline to be presented. And introduction. Bloom filter is most extensively used probabilistic data structure for membership query. Bloom filter is used to boost up query response time, and it avoids some unnecessary searching. Bloom filter is a small size data structure which used tiny size of memory from RAM. So Bloom filters have immense query response time cumulatively. There are various kinds of bloom filter available and also match enormous applications. In spite of several variants of bloom filter, there is a false positive issue with bloom filter. Many applications unable to tolerate false positive. For instance, the application and password management system. Contemporary bloom filter do not provide high accuracy bloom filter. In this HFil, we present high accuracy bloom filter by deploying multi-dimensional bloom filter. HFil provide variants of HFil, 4-level HFil, 6-level HFil, 8-level up to 16-level HFil. The highest accuracy is achieved by 16L HFil, and which is 99.9, and lowest accuracy is achieved by 4L, which is 98.77%. The lowest false positive is achieved by 16L, and then lowest accuracy is achieved by 4L. The fastest one is the 4L, and slowest one is the 16L. 16L HFil consume lowest on-chip memory for 0 false positive, while for 4L HFil consume highest on-chip memory for the same. The time complexity of insertion and lookup of NL HFil is big of n for large value of n, which is not desirable and it is impractical. So for 4L, 6L up to 16L, the time complexity become constant and it is big of 1. So for insertion of a key, into that HFil, say for example this is 16L, there is 16 bloom filter is provided, and an input item is inserted into the 16 3-dimensional bloom filter. So in the query process, first 3D bloom filter is queried, and if first bloom filter response true, then proceed to the next, otherwise stop. If second 3D bloom filter proceed response true, then proceed, otherwise stop. So this is the lookup process, and this is the insertion process. Equation 1 is used to insert an item, and BIJK is the 3-dimensional bloom filter. So this is the equation 2 is used to query an item from the BIJK bloom filter. So HFil, 4th level HFil is using this equation 3, flag 1. If flag 1 is true, then flag 2 is true, then this conditional statement is given, and all flag has to be returned true, then it will return true, otherwise it will return 0. Similarly, 5th level HFil is 6th level HFil is used by equation 4, and equation 5 is equation 5 is nth level HFil. So all nth 3D bloom filter has to respond true, then a flag become true, otherwise it become false. So in our experimentation, we have used random data, which is that 8 million, 16 million, 32 million, 64 million, out of which there is a unique numbers and duplicate numbers. So here false positive, this is x-axis represent individual 3D filter size on 8 million input, and y-axis represent a number of false positive, and this represent 4L, 6L, 8L up to 16L. From 2 MB, 16L, from 3 MB, 16L false positive of 16L become 0, and from 5 MB, 14L become 0, from 6 MB, 12L become 0, and so on. Similarly, this is for 16 million input. That number of false positive and number of false positive in y-axis, and this is the size of Bloom filter, 3D Bloom filter, individual size of 3D Bloom filter. And from the 8 MB, 16L become 0. False positive of 16L become 0. So 16L consumes here again 32 million input. 16L consume lowest 10 MB to make false positive 0. Again 64 million input, for 64 million input 16L consume 30 MB and false positive 0. In the again 128 million input, 16L consume 66 MB and false positive 0. Here 256 million inputs and 16L consume 172 and false positive 0. So this is memory consumption of 3D Bloom filter, individual 3D Bloom filter, and in 8 million input. So highest memory consumption is that 16L, and lowest memory consumption is that 4L. Similarly, this is individual 3D Bloom filter for 16 million input, and highest is 16L, lowest is 4L. And similarly, this is for 32 million input, and this is for 64 million input, and this is for 120 million input and 256 million input for memory consumption measurement. So here is that performance measurement. Performance is this is x-axis, y-axis represent time in second, and y-axis represent random number in millions, 8 million, 16 million up to 256 million, and this is lower is better because 4L performance of 4L is the highest, and the slowest one is that 16L. This is 16L for 8 million, and 16L is the slowest. Here 4L is, this is for 4L, and this is for 16L. As we see that this figure, that 16L is the slowest and fastest one is the 4L. Here performance throughput of various level of HFil, higher is better. 4L has the highest throughput, and 16L has the lowest throughput. So this is y-axis represent million operation per seconds. So this is the false positive analysis of 4L. If false positive is FPP, then it will be multiplied, and I to 0 to 4 false positive of I, and similarly this is 6, and for nth it will be multiplied. So thus accuracy of various level of HFil, 4L is accuracy is 98.77, and 16L accuracy is 98.99, and false positive is nearly 0. And if we increase that NL, then false positive is 1 divided by 3 to the power n, and accuracy is 1 minus 1 divided by 3 to the power n. So trade-off, there is a trade-off between among performance, accuracy and memory. As we have seen that if we increase the performance, then we have to lose accuracy, or if we increase the accuracy, we have to lose performance. Similarly, for 16L, it uh, it uses least amount of memory to make high accuracy. So, in the conclusion, in this paper, we present a high accuracy Bloom filter called HFil. HFil deploys multi-dimensional Bloom filter to implement high accuracy Bloom filter. Generally, HFil is termed as NL HFil, where N is 1, 2, 3, 4, up to N. So, N is large value of N is undesirable, and if it is very large, then it become time complexity become big of N, which is impractical in nature. So in our experiment, shows that 16L HFil has achieved the highest accuracy, which is 99.99%, almost equal to 100%, and its false positive is almost equal to 0, and time complexity is big of 1. This kind of Bloom filter is applicable in various research domains: big data, cloud computing, bioinformatics, IoT, biometrics, and many other research domains which can be, this kind of Bloom filter can be deployed. So this is my references. So thank you very much.
चलेगा ऑफ कैसे करते हैं?